Hi everyone, so welcome to the next lecture of thermodynamics, chemical engineering thermodynamics. I hope you remember the last topic we have discussed. So I told that some topics are left, right? That is in our ideal gas equation of state. We have started with this equation. If you remember ideal gas equation of state, what is the ideal gas equation of state? P into specific volume is equal to R into T. The same equation we know how to convert it into PV is equal to N into universal gas constant into T, right? So this equation, I hope you remember how to write this. In this, what is the value of universal gas constant, right? So universal gas constant divided by our molecular weight is equal to what? Your value of gas constant. That also we know, right? So that things already we have discussed. Now if you remember, right? Now if you remember, we told this gases behaves ideally, right? Gases behaves ideally at what? We told at low pressure and high temperature, right? So this is our first case, and this ideal gas equation of state is developed based on two assumptions. मतलब हमारा जो ideal gas equation of state है, मतलब ये जो equation है, right? So this is actually developed based on two assumptions. What are those assumptions? वो हम पहले देखेंगे, right? So what are the two assumptions? First assumption, right? So first assumption is our gas molecules possess no volume, right? So gas molecules possess no volume. That is our first assumption, right? That is, if you take a gas in a container and we are not considering, that is again our two assumptions. Simply I will start from the beginning. Our two assumptions in ideal gas equation of state is based on the microscopic behavior of the gas molecule. For example, आप यहाँ पे देख सकते हैं, this is a container. In this container we are having a gas. So our assumption of this ideal gas equation of state is based on what? The microscopic behavior of the gas molecule. ठीक है? So our first assumption is based on what? The gas molecules, right? So we are not considering the molecular volume or the volume of the gas molecules. We are not considering the volume of the gas molecules, or we can say that the molecules have no extension in space. That is, this is our first assumption, right? If you want, you can write that is molecules have no extension in space. मतलब we are not considering the molecular volume. That is, this gas is combined of what? Very small molecules, right? We are not considering the volume of that particular gas. So you can write it. So this is our first assumption in ideal gas equation of state, right? Or we can say they possess zero volume, right? So we are saying the gas molecules possess zero volume. This is our first assumption. ठीक है? So that is our gas molecule possess zero volume, and the major assumption or the second assumption we can say is there is no molecular interaction between the gas molecules, or we can say the gas molecules, they do not interact with each other, right? So remaining you can write it, right? So I hope you understood two of the assumptions. Both assumptions are based on what? The microscopic behavior of gas molecule. ठीक है? So the microscopic behavior of gas molecules, based on that what they are saying, if you consider a gas, we are saying the gas molecules have no extension in space or they possess zero volume, because if you compare the total volume of the container or total volume of the gas, molecular volume of the gas molecule, right? Molecular volume of the gas is very small, right? So it is insignificant. ठीक है? Like there is no need to consider that volume. Again, we say what? There is no interaction between themselves, right? There is no molecular interaction. So these are the two basic assumptions for developing this equation of state. This is one reason why we are saying this ideal gas equation of state is valid only for low pressure and high temperature. Is it okay? Because of these two assumptions, right? क्योंकि हमने ये assumptions के ऊपर हमने ये develop किया, right? We have developed this particular ideal gas equation of state based on these two assumptions. So that is the problem. That's why we are able to apply this equation for only these two cases. Think it logically, right? What will happen if we increase the pressure? That is low pressure, okay, it is ideal behavior. But when we increase the pressure, what will happen? When we increase the pressure, gas molecules will come closer, right? So when the gas molecules will come closer, there will be a molecular interaction, right? And your molecules volume will also get significant, right? When you go for high pressure, right, when you increase the pressure, what will happen? Logically you can think, right, your molecules will start to interact with each other, so you cannot you cannot neglect the molecular interaction, or you cannot neglect the volume of the molecules, right? So that is why we have a limitation. That is, our ideal gas equation of state is applicable only to low pressure and high temperature. Clear? So this is the problem. Now we can see, right, now we can see, other than this ideal gas equation of state, you have a new equation of state. What is that? Van der Waals equation of state. Van der Waals equation of state. What is the meaning of equation of state? Equation of state, we have already discussed this. Equation of state, any equation that relates the pressure, specific volume and temperature of gases is called equation of state. And already we have a ideal gas equation of state. So what is the use of Van der Waals equation? Right, हमारे पास already ideal gas equation of state है, फिर what is the reason of developing this Van der Waals? क्योंकि we have a limitation, right? Ideal gas equation of state के लिए हमारे एक limitation है, that is we cannot apply this for high pressure or low temperature. We cannot apply this, right? So for removing this limitation, we are introducing what? Your Van der Waals equation of state. Clear? So what is the equation of Van der Waals, or what is your Van der Waals equation of state, if you remember? Your Van der Waals equation of state equation is P plus A by V square multiplied by V minus B is equal to RT. Again V, it is your same specific volume. Now आप यहाँ पे देख सकते हैं, what is the difference between these two equations? This is your ideal gas equation of state. This is your Van der Waals equation of state. This is your Van der Waals equation of state. What is the difference? हमने दो चीजें ऐड किया है. That is, what are the things we have added? A divided by V square is added. We are added another term B. The two terms we have added, right? Two terms. So what we are saying is, right, we can rectify all the problems or all the limitations of ideal gas equation of state by adding two terms. So what should be that two terms? The limitation of ideal gases, right? That is, out of these two, one will represent the molecular volume and one will represent what? Molecular interaction. Kyunki that was the limitation, that two were the limitation of ideal gas equation of state. So we have added just two terms in the ideal gas equation of state, so that your first problem in ideal gas equation will be solved and your second problem in ideal gas equation will be solved. I hope you understood. Right? I hope you understood. So write this equation, that is Van der Waals equation of state. So if you want, you can write it, right? And you can write it, that is, to improve the ideal gas equation of state. That is, to improve the ideal gas equation of state, two new terms are added, right? Two new terms are added. This A by V square term will denote your intermolecular attraction. Right, so this A by V square term will denote the intermolecular attraction forces. Intermolecular attraction forces, you can write it. And B will represent, right, the B will represent volume occupied by the molecules. Volume occupied by the molecules. Clear? So this is the meaning. So to complete this, right? So I hope you can understand, that is, ideal gas equation of state is valid for only low pressure and high temperature. When we increase pressure, what will happen? This volume occupied by the molecules and the molecular interaction will be significant. Right, so to add that particular two effects, we are adding two terms. Right, out of this A and B are constants. Right, A and B are, we can say, Van der Waals constants. Now we need to discuss the most important question, right, in our gate, that is how to find the value of A and B here, right? That is, we have two constants, right? In the equation of state you have two constants. So how we are going to find this particular values of these constants? So how can we find this is based on your inflection point, right? This is the application of your inflection point. If you remember inflection point, what is inflection point? The critical point is your inflection point. So what is inflection point? I told you in the last class to go and check, right, what is the speciality of an inflection point. That is, a function goes on increasing and suddenly after one point, if it is decreasing, right, it is changing its direction. So then we can say what? It is an inflection point, right? If you remember maxima, minima, right, maxima, minima, inflection point, right, that is, if we say dy by dx is equal to 0 and d square y by dx square is also equal to 0, that particular point we can call it as what? Your inflection point, right? That particular point we can call it as the inflection point. So if you didn't understand how we are writing this, in the last class also I told, go to your mathematics lectures where we have discussed, right, this inflection point, and just you can search in Google, right, what is the meaning of inflection point, right? So I don't have time to explain that also in this thermodynamic lecture, so go back to mathematics. So these topics are important for your gate. Maxima, minima, this inflection point, these based questions they will be asking. Okay? So यहाँ पे, if you are drawing pressure volume diagram, what is the speciality at critical point or inflection point? Instead of y, it will be dp by dv. Here it will be d square p by dv square. So by differentiating this equation and by putting dp by dv equal to 0 and by double differentiating this equation and equating it equal to 0, you are going to get the value of A and B, right? You are going to get the value of A and B. So your if you want, you can write it, right? So the determination of van der Waals constant is based on the inflection point or your critical point. Clear? It's based on your inflection point or critical point. So we have discussed the critical point already, where this will be your saturated liquid line, this will be your saturated vapor line. Saturated liquid line and saturated vapor line is forming a dome at the critical point. Those who didn't understand, go back to the last lecture, lecture number 3. Clear? So go through that, study what is inflection point and again come back. So these two you have to remember because there are 3 or 4 questions in gate based on this. Clear? ये भी समझ लो. ठीक है? I hope you understood. Now, if you ask me whether you need to remember the value of A and B, it is your choice. Okay, whether you want to remember the value of A and B, or if you want, you can derive it, right? That is by applying these two things, that is dp by dv is equal to 0, d square p by dv square equal to 0. By applying this, you can find the value of A and B, right? And if you want to remember that, it is your choice, right? Sometimes they can ask, but so far in gate, based on the value, they haven't asked any question. लेकिन आपका जो PSU exams है, right? So that is several public sector exams are there. So in that, sometimes they can ask. Clear? So if you want, you can remember it. That's all, because so far in gate they haven't asked. Okay. The equation I will write anyway. It is 27 r square I think the equation is correct. That is, let me check. So it is 27. R is your gas constant into critical temperature square divided by 64 critical pressure, right? So this is the equation for A. This you will get once you do the substitution, right? Once you do the substitution. B, value of B is R into critical temperature, right, divided by 8 into critical pressure, right? R into critical temperature divided by 8 into critical pressure. So you can write this. So I hope you understand this, right? So that is the end of your equation of state, right? That is the end of our equation of state, and there are minimum 3-4 questions in GATE, right? So we will solve this in our next thing, right? So I will give you the questions, so we will solve in the class itself. There are only 3-4 questions. Clear? So go through this and understand what we are doing. So those who are having still confusion, what is inflection point, go back to the last lecture. Clear? So this is a GATE 2005 problem. So those who want to solve it, right? So just pause this video and solve this, right? So I will read the question. In van der Waals equation of state, what are the criteria applied at the critical point to determine the parameters A and B? Okay, so as you can see, it is our GATE Academy booklet. So this is our previous year book. So we can see here. And so those who already have the book, you can see the book, okay, GATE 2005 question paper. So now in this, what should be the answer? So obviously just now we have discussed on the board, that is dou P by dou V and dou square P by dou V square. What should be the values, right? What should be the value? So if you remember our diagram, that is at critical point, if you draw PV diagram, so both first derivative and second derivative should be equal to 0 at the inflection point. Okay, so I hope you understood. So the option will be what? Your option will be option A. So this is your GATE 2005 question. Clear? I hope you understood. Now we will see the second question, that is, this is from IIT Bombay 2013 question paper. So you can see 2.42 question number. An equation of state is explicit in pressure and cubic in specific volume V. At the critical point C, the isotherm passing through C satisfies. Again, you can see the options. Right, I hope you have seen the question. Those who haven't seen the question, just pause the video and read the question. It is GATE 2013 question, right? Now you can see which are the options. Again, the same answers will be coming in. That is option D, that is dou P by dou V and dou square P by dou V square, both will be equal to 0. So this is the second time they have asked the same questions based on your equation of state. So whenever, if you want to find the value of, right, that is your constants, or if you want to find if you want to know the speciality of the critical point, so critical point is a point of inflection. So both the first derivative and the second derivative will be equal to what? 0. Clear? I hope you understood. Now this is the third and last question from the same topic, that is, which of the following condition, this is GATE 2002, remind you, right, that is IIC Bangalore, GATE 2002, that is, which of the following conditions are satisfied at the critical point? Clear? Which of the following conditions are satisfied at the critical point by the PVT relation of a real fluid, right? By the PVT relation of a real fluid. So you can see here, so they have given at critical point, what is the speciality of critical point? As we already explained you in detail, that at critical point what happens? It is an inflection point. So both your first derivative and second derivative will be equal to 0. So dou square P by dou V square and dou P by dou V at constant temperature will be equal to 0. I hope you understood this. So these are the 3 questions, right? So I hope you can see the board once again. So this is just the same thing what I have explained so far. Clear? That is, your both first derivative and second derivative will be equal to 0 when you draw the diagram. Clear? That is, even though if you are drawing process diagram PV, right, when you draw PV diagram, what we have to keep constant? We will be keeping which thing constant? If you are drawing TV diagram, pressure will be constant. If you draw PV diagram, your temperature will be constant, right? Temperature will be constant if you remember the graph, right? So I hope you understood. So this is the point called critical point. So we already told it is a critical point is a point of inflection. That is, our graph is changing its shape at that particular point, inflection point. What is the speciality of inflection point? We will say both dy by dx and d square y by dx square both will be equal to 0. Now you can equate both equal to 0. By this, by using these two things, if you want further information, what you can do is differentiate these two equations. That is your van der Waals equation of state, differentiate it, put it equal to 0 and check whether you are able to get the value of A and B we have written. Clear? So I hope you are able to find this, right? So that is our question. Clear? So we have done 3 questions also based on GATE from these 3 things, right? I hope you understood this. So this is another question, right? So from your gate you can read the question. Parameters A and B in the van der Waals and other cubic equation of state represent, right? So you can see the question number given here, right? So it's also a gate question, right? So if you see that, it's a gate 2007 question, right? Parameters A and B. So I hope just now we have explained, right? What is parameter A, what does parameter B represent, right? So obviously I hope you remember A and B. So based on that you should be able to write this, right? So that is, your A represent your molecular attraction and your B represent your molecular space, or we can say the volume of that particular molecule, right? So molecular size and molecular attraction. So if you see option A, molecular weight and molecular polarity, that is not correct. Molecular size and molecular attraction, right? Option B, but it is not correct because they have interchanged it, right? Because your A denotes, or your A by V square, that entire term denotes your molecular attraction, and the second term denotes what? That is B denotes the molecular size. So answer will be option D. Clear? So this is another gate question from gate 2007. I hope you can understand that question as well. So I will give you one more question as a homework. Again, this same type of question we have done in our last class. So you can read the question. A new linear temperature scale denoted by degree S has been developed. The freezing point is given 200, boiling point is given 400. On the scale 500 correspond to. So this is a gate question. I think we have done this in the class as well. So since I was going through this gate book, right, previous year book, I just wanted to share that this is also a gate question, right? It's in the gate 2010 question. So this we have already solved. So this is also another question. So go through this as well, right? So that is the end of this chapter. So now we are starting the new chapter. Clear? So always it is important to solve the previous year questions, otherwise there is no point of discussing all these things, okay? So I hope you understood this. So let me start the new chapter. So now we are starting our new chapter, that is the most important chapter in your chemical engineering thermodynamics. That is, so the chapter name is your first law of thermodynamics. I am not going to write it here, right? So we have what, right? So we have basically first law of thermodynamics. That is, I hope all of you know what is first law of thermodynamics. Though at that iconic statement, तो आपको सबको पता है, that is energy can neither be created nor be destroyed. It can only change forms. These things are okay. But what you need to understand is, right, so how we are going to write that particular equation, right? That is your first law of thermodynamics as an equation, and how we are going to apply that equation to an open system or closed system, or how we are going to apply this first law of thermodynamics into an open system and closed system. First of all, what are the differences between open system and closed system? That we have already discussed. Still, right, I am just explaining once again. ठीक है? तो यहाँ पे आपका जो closed system होगा, there will be only energy interaction, right? So there is no mass interaction. ठीक है ना? That is, there is no mass transfer, right? Only energy will be transferring in a closed system, right? If it is closed. So what was the example I told for a closed system? Lunchbox. Okay, I hope you remember the example of lunchbox, because if you are packing a lunch in a lunchbox, right, since it is closed, there will be no mass transfer. The lunch will not go out unless you open it. ठीक है? तो अगर ओपन नहीं किया तो there will be no problem, it will remain as a closed system. लेकिन जो हीट होगा लंच के साथ, जो भी अपना जो भी खाना है उसके साथ जो भी हीट एसोसिएटेड होगा वो बाहर चले जाएगा. Right, so that will go out, heat will go out, so there will be an energy interaction. ठीक है ना? So लेकिन open system में क्या होता है? The major difference is, open system there will be some mass coming in. Sometimes it may go out also. Sometimes it may not be going out. Right, no problem. So we are saying it is mass coming in, mass going out. So इसके example मैंने बोला था open system के लिए water heater, right? So water heater in the sense cold water आ रहा है, right? After some heating we are getting an uninterrupted hot water. So this is an open system, right? So now we are interested in application of the first law of thermodynamics into both the system, right? Into both the system. And let me remind you one thing, majority of your questions in GATE are based on the closed system, right? Based on the closed system. So understanding this is very much important. So we will start with the basic things, right? Start with the basic things. That is, you can see here, first topic in this particular chapter is to understand what is a process and what is a cycle, right? These things you already know, okay? What is process, what is cycle, these things you already know, right? That is, if I say, right, this is my one equilibrium state and this is my second equilibrium state, right? So the change from one equilibrium state to second equilibrium state is called a process, right? So already we have discussed this, that is one equilibrium state means the properties have a fixed value at that particular state, right? All the property, if you remember, मैंने फर्स्ट क्लास पे ड्रॉ किया था ये, मतलब लाइक मास दिया हुआ है, इसका वॉल्यूम दिया हुआ है, राइट? दैट इज व्हाट आर द थिंग्स, टेम्परेचर इज गिवन, प्रेशर इज गिवन, सब कुछ है. अगर एक भी वैल्यू चेंज हो गया, मतलब अगर एक भी प्रॉपर्टी चेंज हो गया, तो दैट विल बी ए न्यू इक्विलिब्रियम स्टेट. क्लियर? दैट विल बी ए न्यू इक्विलिब्रियम स्टेट. अगर मैंने यहाँ पे I have drawn P and I have drawn V, this will become now what? It is a pressure volume diagram. So first state पे your value of pressure will be what? First state, this will be the value of pressure. First state, what will be the value of volume? This will be the value of volume. Second state, you have a new pressure value, you have a new volume value. If it is an isobaric process, this line will come as what? Straight line. Isobaric process. If it is a constant pressure process. Clear? So this type of diagram is called process diagram, right? This type of diagram is called process diagram. These are drawn to visualize the process. ठीक है? For example, ये कौन सा टाइप का प्रोसेस होगा? अगर my pressure is changing, right? So हमें पहले ये करना है, we have to show the direction. So if I show this direction, so I am saying from first equilibrium state to second equilibrium state, this is the path followed by the process, right? If you want to represent a process, always you should, initial state you should specify, final state you should specify, and you have to specify the direction also, right? You have to not direction, we can say you have to show the path as well. Why I am saying so? Because from first equilibrium state to second equilibrium state, you can go by this path as well, right? Right, you can go to any path, by any path you can follow that, right? So why we are saying the path is important? Because we have to mention the path, because then only we will be able to specify a process. Clear? Because 1 to 2 process and this process is not same, right? Because this is a path A and this is a path B. Clear? So I hope you understood the concept of process, right? I hope it is clear. That is, from one equilibrium state to another equilibrium state, that particular change is there means we can call it as what? A process. Clear? So I hope you understood. That is, any change that the system undergoes from one equilibrium state to another equilibrium state, sorry, right? Any change that a system undergoes from one equilibrium state to another equilibrium state. Clear? Clear? If it is an isobaric process, means constant pressure, means we will have a straight line, because first point and second point will come in the straight line. Logically you can think. Clear? So this is the meaning. So instead of pressure and volume, you can have any other temperature volume diagrams as well, right? No problem. Temperature, pressure diagrams, no problem, right? It depends on the question, right? It depends on the question. So this type of graphs are called process diagrams. To visualize this process, we are using this. Clear? Now I think this is also done. Now what is the meaning of cycle? Cycle meaning is your initial and final points will be same. That is, 1 to 2 is a process and 2 to 1 is also a process. So 1 to 2 is our process and 2 to 1 is also a process. Now it completes a cycle. That is, for cycle, initial and final values will be same. Is it okay? For the cycle, the initial and final values will be same. So this also you can understand, right? I hope you understood this. Process, cycle is done. 1 minute, let me take another color pen. So the series of points, right? So series of states, we can say, from reaching from point 1 to 2. If I take this one back, right? I am interested in the process 1 to 2. So I am saying from reaching, we are starting from state 1 and we are reaching finally state 2. So the series of states through which the process is changing, right? So the variable is changing. The series of equilibrium states, we can say, because if you see, from each of the point is a new state, because the value of the property is changing. Right, each of that value is different, so definitely we can call it as what? Different state, right? So what we are saying is that series of states through which a process changes, right? Series of states, right? That particular series of states through which a system passes during a process, right? That is series of equilibrium states through which, that is point this one, this one, this one, this one, this one, like this. The series of states through which the system passes is called the path of the process, right? If you want to describe a process, आपको पहले initial point और final point specify करना पड़ेगा, उसके बाद आपको path भी specify करना पड़ेगा. That is, you have to specify both initial and final point and the path of the process. Then only you will be able to describe a process completely. Clear? I hope up to this is clear. Done, right? So up to this is done. If those who want to write it, you can write it, process, cycle, etc. Clear? So if I say this 1 to 2 is a process, what kind of process is it? You can see here, from 1 to 2 your pressure is decreasing and your volume is increasing, right? So if the pressure is decreasing, volume is increasing, means it will be an expansion process. Now if I draw this diagram in the opposite direction, right, draw it in the opposite direction, process 2 to 1 will be what? It will be a compression process. Why? Because your pressure is increasing and your volume is decreasing. Clear? So I hope you understood that, right? So this is the meaning. Now, right, now the most important part is all the properties are, right, all the properties are state function, right? All the properties, you have to remember this very carefully, all the properties are state function. What is the meaning of state function? All the properties are state function. For example, if I draw a diagram like this, so this is my first equilibrium state and this is my second equilibrium state and this is the path of the process. Now even though if I change the path of the process like this or like this, right, if I change the path of this process, my change in property will be what, right? My change in property will be the same because your property change, that is the delta T, right? For example, if my temperature change between point 1 and 2 will always be what? Temperature at the second state minus temperature at the first state. What will be the value of delta P during process 1 to 2? Right, so delta P will be what? It will be the pressure at state 2 minus pressure at state 1. What will be the change in internal energy between process 1 to 2? It will be the final internal energy minus the initial internal energy. Right, what will be the change in the volume? It will be V2 minus V1. Because all the properties are state functions only, because that does not depend on path. Because all the property, for example, if I say, right, if I say at point 1, right, if I say at point 1, what is the temperature? T1, right, what is the volume? V1, what is the pressure? P1, right, so there is no change. So if you go this way, this way, this way, finally, ultimately you are reaching the point 2, right, so that is a different state. So at that state, your value of volume will be what? V2, temperature T2, pressure T2, internal energy U2. Right, so when you say the difference between these two, that is the change in those value, obviously your answer will be what? Right, your answer will be T2 minus T1, P2 minus P1, like this. So this type of functions are called state function. That does not depend upon the path which is following, right? So path is independent. We can say path independent function, right? It depends on only state of the particular cases. Now you can see what will be the value of state function for a cycle. Now if I say like this, it is going back to this. For a cycle, what will be the value of property change? It will be 0 because delta T for this particular process will be what? Final value is T1. Initial value was also T1. So T1 minus T1, 0. Right, so property change for a cycle, all the property changes value will be 0 if it is internal energy and enthalpy or whatever we are going to write, so that value will be 0. Right, so what are our path functions now? Right, state functions we have already discussed, right? State function we have already discussed. So what kind of things, right, will change during this path? That is, we know with respect to state, these things are changing. Right, so there will be something, right, that will change upon the path. right? There will be something that will change upon the path. For example, you are going from, right, you are going from, for example, any place, that is, this is Pune, right, you are going to Mumbai. You can use two various routes, right? So finally the temperature change in Mumbai and Pune will be what? Temperature in Mumbai minus temperature in Pune. No change in temperature. Clear? Same meaning, right? Same meaning. But if you go through the express highway and if you go through the old Mumbai Pune highway, the energy required will be different. Clear? If you use the express highway, you may reach in 4 hours or 3 hours. But if you use the old highway, you may require what? More than 5 hours. Clear? The energy will be different. The energy needed may be different. That is, your heat requirement or work requirement both will be different for different path. So your heat and work both are your path function. Clear? Heat and work both are your path function. I hope you understood. So this is the first thing you need to understand. Clear? State function is clear. Now we will discuss about the path function more, or your heat or work again more. Now you can see here, since our chapter is about closed system, आप यहाँ पे देख सकते हैं, that is, this is a closed system. So whatever energy interaction with the closed system is either due to heat or due to work, either due to heat or due to work, है ना? कोई डाउट नहीं है ना? मतलब आपका जो क्लोज सिस्टम होगा ना, क्लोज सिस्टम के अंदर जो भी वर्क होगा, जो भी एनर्जी ट्रांसफर होगा, राइट, वॉट एवर रीजन फॉर दिस एनर्जी ट्रांसफर इन ए क्लोज सिस्टम, दो ही ऑप्शन हो सकता है, दो ही रीजन हो सकता है एनर्जी ट्रांसफर का, दैट इज हीट ट्रांसफर, नहीं तो वर्क ट्रांसफर, राइट? हीट एंड वर्क ट्रांसफर, दिस इज द ओनली टू इंटरेक्शन वी हैव. इफ इट इज एन ओपन सिस्टम, आपको एक तीसरा पॉइंट आ जाएगा, दैट इज मास विल कम इन, मास विल गो आउट, that mass will carry some energy, so that will also come. Clear? So the energy transfer in a closed system is only due to what? Your heat and work. ठीक है? Up to this is fine. Now we will see energy transfer by heat. Right? We will see energy transfer by heat. So what is the meaning of energy transfer by heat? Why there is an energy transfer by heat? Obviously you have learned heat transfer, so you know if there is a temperature difference, there will be an energy transfer by heat. Right? During a process, right? During a process, if there is no heat transfer has happened, then we can call it as what? Adiabatic process. Clear? So these things, small things you already know, right? I hope you understood. Clear? So if there is an energy transfer by the temperature difference, right? Due to the temperature difference, if there is an energy transfer, we will call it as what? We will call it as a heat transfer, right? Now what about the work transfer? Work transfer is the energy transfer associated with a force acting through a distance. Right? I hope you remember, right? Joule is Newton meter, right? If you remember, the energy 1 joule is equal to 1 Newton meter. So force acting in meter distance, right? Force acting through a distance is what? It is our energy, right? It is our work, we will say, right? So work transfer is associated with this, right? So work transfer is associated with this. So these things are your two type of energy interaction. Clear? I hope you understood. Now I am going back to the sign convention, because the sign convention we follow is very much important to us. So we will once again, I have explained the sign convention in detail in our first lecture of thermodynamics. If you want, you can go back and see, but still, right, the sign convention we follow as a chemical engineer is, you can see here, this is a closed system, right? This is a closed system. Whatever heat coming into the system, heat added to the system is positive, heat lost by the system is negative. Mark it. This is the same sign convention all over the world for every branches. This sign convention is clear. Heat added to the system is positive, heat leaving from the system is negative, or heat loss will be always negative. Clear? No doubt. Now, right, now we have work done, right? You can see this work done on the system, right? Work done on the system. For chemical engineers, I am specifying this word chemical engineers given by IUPAC. We follow this sign convention in our chemical engineering books, including Smith and Varness, and including the latest version of K.V. Narayanan. Every book, right, we follow, that is chemical engineering books like Koretsky, right, Milo D. Koretsky, right? So all the chemical engineering books, we follow this sign convention, that is work done on the system is positive for us. work done on the system is positive for us. Work done by the system is negative. It is a very easy sign convention. That is, whatever energy coming into the system is positive. That is right. If I get some energy, I will become strong. So that both are positive. Right. If I am losing some energy, whatever energy is it is a heat or by work, everything is negative. It is the negative energy. Right. So this is the easiest sign convention we have in a chemical engineering for students. I have seen lot of faculties who are chemical engineers, they have used the second sign convention, because the reason is very simple, because almost in all the mechanical engineering books, or normally thermodynamics 1 is handled by the faculties, mechanical engineering faculty, so they teach the opposite sign convention. That is, the opposite sign convention is, they will take work done on the system negative, work done by the system positive. ये reason तो मैंने बताया था आपको. That is, for mechanical engineers, the why the sign convention is opposite, because उनका जो criteria है, like उनका सब कुछ they have explained it with the basis of internal combustion engine, that is their IC engine or heat engine simply. Right. For mechanical engineers, work done by the system is important. That is, whatever work we are getting from a car engine, they can use, or a heat engine, they can use for what? Driving car or driving aeroplane or whatever thing. But for a chemical engineer, work done on the system is important, because we are interested to run a chemical reactor. Right. So we are interested in how much work we should give to the system so that, right, our chemical reactions will happen. Clear? So our sign convention is always this, that is, work done on the system is positive and work done by the system is negative. Is it okay? So this is the sign convention we are going to follow. Right? I hope up to this is clear. Right? So those who are having still confusion, right, you can see the mechanical engineering books and chemical engineering books. And let me remind you, right, if you study the opposite in your college, or if you study the opposite way also, your answer is not going to change in the exam. Because if they are asking work, what is the work done by the system, and you may be getting, as a chemical engineer, we may be getting minus 100 joule. But in the option, right, there will not be 100 joule also. 100 joule and minus 100 joule will not be there in the option. Right, so that is a fact. And if they are asking you this kind of question, they will specify the sign convention in the question paper, because in our chemical engineering reference books, this sign convention is followed. So they have to give you two answers. Right, that is, they have to give you the sign convention they are using. Otherwise, we won't be able to solve the question, or we won't be able to get the correct answer. Clear? So, and I have seen this in some test series, because normally Thermo 1 question is prepared by a mechanical faculty. So what happens is, they will keep work done by the system will be the question. They will keep option A minus 100, option B 100. So those who are ticking, as a chemical engineer, when I solve, I will get this and I will get a negative marking. Right? That happens in test series because they prepare only one sign convention. Right? So both answers they cannot give in the option. Clear? So this also you can understand. There is a gate question specifying these two sign convention as well for chemical engineers. That also we will solve in the class. Clear? So remember, first condition you should remember is wherever you go to an interview, whichever sign convention you are following, you should be able to convince them that this is the reason why chemical engineer is following a different convention and why mechanical engineer is following a different sign convention. Clear? Because you should be able to explain, otherwise they will say like you are saying a different thing, right? So because in all the mechanical books the opposite is given, but you should be able to convince them that I am a chemical engineer, so our sign convention is UPSC. Clear? I hope up to this is clear. Now we will go forward. Clear? So just now I have already told you that is your heat and work both are path function, right? So your heat and work both are path function. So I am drawing here one more diagram. That is again the same diagram, okay? That is we have a process from point 1 to 2, right? Any process, I am not saying any which process it is, any process happening. So what is the change, right? What is the change in temperature? I will write the change in temperature is dT, change in internal energy is du, change in pressure is dP, anything. So if I am integrating this dT over this 1-2 process, I can integrate it like this, dT over 0.1 to 2, and what will be the value will be T2 minus T1. Easy. Integration of du, right? Because if you see why I'm integrating, right? Why I'm integrating? Because each and every point it is a equilibrium state, right? Because if there is a change in first state to small value also, it is a change, right? We are not having the same value. For example, if this is temperature, okay, if this is temperature, I'm saying this value is different, this value is different, this value is different, like this it is changing. So what we are doing, we are taking a value of dt and I'm integrating from 1 to 2. So it will be T2 minus T1. I can easily integrate. Same way, what will be du over 1 to 2? It will be u2 minus u1. Because I can integrate this completely because these are point functions or state function, right? Point function or state function, it depends on only initial point and final point. Clear? So this is the meaning, right? This is the meaning. Now, right now, what we are going to say about heat and work is, we cannot represent heat and work by dt and du. That is, I cannot represent this by dq and dw. Even though in some textbooks they have represented it like this. Normally, right? Normally, if books like Sengel, what they say is, we can never write dq and dw, because when you write dq, meaning is what? If you integrate from 1 to 2, it will be q2 minus q1. Clear? If you integrate from 1 to 2, it will be q2 minus q1. That is, for example, same logic. If I apply the same logic here, if I write dq, that is heat transfer from 1 to 2, if I write it is q2 minus q1, this statement is wrong, because there is no concept of heat at a particular point. It is not a point function, right? There is no concept of q1 at that particular point. It is the heat transferred in between 1 to 2. During that path, we have a heat transfer, right? So we will be integrating, you can see here, 1 to 2 del q. You have to remember this del q, because it is to indicate that your heat is not a point function or it is not a state function, it is a path function. So I will be writing after the integration like this, q1 to 2. That is, it is the heat transfer during the process 1 to 2. Same way, integration of 1 to 2 del w, the meaning is, it is the work transferred during 1 to 2. It can be work done on the system, work done by the system, whatever. Clear? So remember these things, dt and del q, del w, etc. Right? You will not be able to write, you should not write del q is equal to, or whatever heat transferred is equal to q1 minus q2, q2 minus q1, you cannot write it. Clear? So this is the meaning. So this also you need to understand. So that is the difference between what? Your state function, path function, etc. Clear? So in our chemical engineering, right, or in your thermodynamics, we have only two path function, that is your heat and work. Clear? All the other properties are your state function, right? So you have to remember that. Clear? Clear? So I hope you understood this as well. Now we are going for the equation of first law of thermodynamics, right? So you know the definition of thermodynamics, first law of thermodynamics. I'm not going to specify it once again. Those who need that statement, you can go and read the textbook. After every class, try to read the textbooks. Okay, you will get more and more information. Now, what is the meaning of first law of thermodynamics in closed system? How can we represent first law of thermodynamics in a closed system? You can see we have a system, we have a gas inside that or whatever, right? It is a system. Now, whatever change in internal energy of the system, right? See, we have some internal energy, right, for that particular system. That change in that internal energy is due to only two reasons. Clear? The change in that internal energy is due to two reasons. What are the reasons? What can be the reasons? The reasons are, one can be your heat transfer and the second can be your work transfer. Right, it can be coming into the system, going out of the system, doesn't matter. Your equation, your definition is based on the addition, that is heat added into the system, work done on the system. So our first law of thermodynamics equation for closed system, you can see here, change in internal energy is equal to, the change in internal energy of a closed system is due to what? It is due to your heat transfer coming into the system. plus del W. Clear? So this equation is based on what? This equation is based on our sign convention. Clear? This equation is based on chemical engineering sign convention. Those who are using mechanical engineering sign convention, obviously what will be the du will be equal to del Q. For us, work done on the system is positive, that's why it is plus. For mechanical sign convention, this is negative. Work done on the system is negative. So del Q minus del W equal to du will be for their sign convention. Our sign convention is based on IUPAC. So this is our equation. Clear? I hope you understood. So there is a problem with my light. 1 minute. So sorry for the sorry for the disturbance. There was some light problem here. So now it is okay. So I hope now you are able to see the board. Right. Now, if you see, right, du is equal to del Q plus del W. When I am writing about a process, what is happening, right? We are having a process inside this particular closed system, right? It can be any process from 1 to 2. If there is a process happening in 1 to 2, how will you write this equation? Ultimately, what you need to find is integral of du, that is delta U will be equal to, right? That is from process 1 to 2. That is, if you have a process from the state 1 to 2, the internal energy change of the system during that process is equal to what? It will be heat transferred from 1 to 2 plus work transferred during 1 to 2. This del U you can write it as what? U2 minus U1, that is final internal energy minus initial internal energy, equal to whatever heat is transferred from 1 to 2 plus whatever work is transferred. Clear? I hope you understood up to this. Right? So whatever internal energy change is there in a closed system from a process, from a state 1 to 2 during a process, any process, that is equal to what? Heat transfer plus work transfer. Clear? Now take some physical example, right? So take some physical example. If there is no heat transfer, right? If there is no heat transfer, if it is an insulated system, there will be no heat transfer. Insulated system, no heat transfer. So what will happen? The internal energy change will be only because of work done. If it is an insulated system, right? Insulated system meaning क्या है? Adiabatic, मतलब no heat transfer. Heat transfer नहीं है तो ये close कर सकते हैं ना आप? Simple. Clear? Another simple equation, right? Simple equation. Like मेरे पास कुछ bottle नहीं है. For example, this bottle. Right? So this is some soft drink bottle. For example, I am saying this is some soft drink bottle. After drinking, I have closed this bottle and I want to keep it in the fridge. Right? मुझे ठंडा पानी चाहिए, so I want to keep it in the fridge. Now remember one thing, when I am putting this particular bottle inside the fridge, the bottle is completely closed. Right? The bottle is completely closed, so there is no work transfer. Right? There is no work transfer. So now you can see, if there is no work transfer from the bottle to outside, right? So if there is no work transfer, what can be the reason of internal energy change? The reason of internal energy change is only what? Due to heat transfer. अगर मैं ये फ्रिज में डाल रहा हूँ, right? If I am putting this particular bottle in the fridge, the internal energy inside, right? The change in the internal energy of the bottle or the content present in the bottle will be due to only what? Heat transfer. ये bottle के अंदर से बाहर we will have a heat transfer. The heat will be lost. Right? Because I want the cold water, right? So from the hot water to outside, you will have a heat transfer. Right? If you keep it in the fridge, you will get a chilled water. Right? It will be a cold water. So if there is no work transfer, the internal energy change of this bottle is only due to what? Heat transfer. Clear? So this is the way you should think. Right? This is the way you should think. So we will see. Right? I hope up to this is okay. Those who wanted to write, you can write it. So this is your statement of what? Your first law of thermodynamics in a closed system. Clear? Clear? So don't be confused, okay? Right? Don't be confused about mechanical sign convention, chemical, both are same here. It's not a difference. So I'm stopping the class today here, but still, right? Don't close the video. You can check here. This W, right? This W12 for chemical engineers is minus PdV. This W12 for mechanical engineers will be PdV. Right? So if you read the book of mechanical and chemical, you can see the difference. So आपको confusion नहीं होना चाहिए. Right? Smith and Vaness में ये दिया हुआ है. So chemical engineer we will be following this. तो आप देख लो equation में क्या change आएगा. Right? अगर मैं ये equation लिख रहा हूँ, right? Those who are writing based on mechanical engineering sign convention, उनका आंसर क्या होगा? उनका आंसर होगा delta U is equal to, right? Their answer will be delta U equal to Q12. What is del W for them? It is PdV. Q12 minus PdV. No problem. For chemical, those who are writing, W12 is what? Minus PdV. So you can see here, both for chemical and mechanical, we are using the same equation. Q12 minus PdV. What is the change? दोनों same है ना? ठीक है? So everything is same. Only thing is you need to understand what is the difference between these two. That's all. Clear? So there should be no confusion regarding the sign convention from now on. आप लोग अच्छे तरह से explain कर पाना चाहिए. Right? You should be able to explain to everyone. Right? मतलब इंटरव्यू पे if they are asking why you are writing minus PdV, क्योंकि आपका सब chemical engineering books में minus PdV लिखा हुआ है. Right? So you have to think why, what is the change? Because mechanical तो PdV लिख रहा है ना. Right? So already I have explained in 2 classes what is the difference. ठीक है? So if you go to an interview, you should be able to explain it to them. Clear? So how we are writing this PdV minus PdV, that we will discuss in the next class. Clear? So we need to explain what is a reversible work, how we are substituting PdV as work done. Everything we will discuss in the next class. Clear? Up to this, I hope you understood. So today we solved some gate questions as well. 3-4 questions we have done, right? And we have started the most important chapter, that is our first law. Now remember, revise all the 4 lectures we have done so far. Go through all the problems we have done so far. Next class is very much crucial, right? Because in the next class we are going to derive everything in the first chapter. Clear? Everything in the first chapter, so that you should be able to solve any question in thermodynamics 1 for chemical engineering. Right? Mechanical engineering question, if you are not able to solve, no problem. Right? Only chemical engineering questions you need to solve. That is previous year gate question. Clear? So we can solve that. Right? So that is the guarantee I can give you. Right? So that's all. So next class we will see. Okay? So that's all. Thank you.